Okay, so I just want to do this example here. So we want to find the line integral of xy squared, where c is the right half of the circle x squared plus y squared equals 16, oriented counterclockwise. Now, the right half of a circle of radius 4 centered at the origin, there's nothing new about that. So x squared plus y squared equals 16 is a circle of radius 4 centered at the origin, and we want the right half of it. So that's going to be this path right here. So C is going to be this curve right here, and we want it oriented counterclockwise. That means that when we travel along the path, we want to be going in a counterclockwise direction. So that means we're going in this direction. So that means what this is saying is that this is the start point and this is the ending point. Remember that the parameterization for this right half of the circle, so it is a circle of radius 4, so the parameterization is 4 cosine t 4 sine t. This is the standard parameterization for a circle of radius 4 centered at the origin. And we want to go from this point to this point. Well, this is minus pi over 2. The angle of this point is minus pi over 2, and the angle of this point is pi over 2. So we want t to go from minus pi over 2 to pi over 2. Okay, so remember the general way that we do an integral like this. The general formula, if you want to do a line integral of a function f over a curve c, this is equal to the integral from t equals a to b f of r of t times the magnitude of r prime of t dt. And here r is the parameterization for the curve. R of a is in the initial point or the starting point of the curve, and r of b is the ending point of the curve. So now we just need to fill this stuff in for our particular problem. Okay, so the left-hand side, this is the thing that we want to compute. This is c x y squared ds. Okay, now the bottom limit is going to be r of minus pi over 2, or sorry, minus pi over 2. So this is t equals minus pi over 2 to pi over 2. This is t going from minus pi over 2 to pi over 2. R prime of t, well, let's do the magnitude of that first. So r prime of t is equal to minus 4 sine t for cosine t. The magnitude of this vector is 4. So this is 4 dt. That's this part, the magnitude of r prime times dt. And now to compute f evaluated at r of t, well, just remember that this is the x of t function, and this is the y of t function. So my f of xy is x times y squared. So wherever I see an x, I'm going to put my expression for x of t. Wherever I see a y, I'm going to put my expression for y of t. So this is going to be 4 cosine t times 4 sine t squared. And this is going to be equal to 4 to the power of 4 times the integral t equals minus pi over 2 to pi over 2 cosine t sine squared t dt. Okay, and we can figure out what 4 to the power of 4 is in a moment. Okay, now to do this integral right here, we want to use u substitution. And we're going to say u is equal to sine t, and then du is going to be equal to cosine t dt. So then this integral becomes 4 to the power of 4. Okay, if du is equal to cosine t dt, this means dt is equal to du over cosine t. So it cancels with that cosine t, which is the whole reason we picked this u substitution. So this will be u squared du. And now the bottom limit, well, if u is equal to sine of t and t is equal to minus pi over 2, u is going to be equal to sine of minus pi over 2, which is minus 1. Okay, and similarly, if u is equal to sine of t and t is equal to pi over 2, then u is going to be equal to sine of pi over 2, which is 1. Okay, and now this, the antiderivative of u squared is u cubed over 3. So this is going to be 4 to the power of 4 over 3 times 1 cubed minus minus 1 cubed. And this is just equal to 2 times 4 to the power of 4 over 3. And 4 to the power of 4 is 256. 4 to the power of 4 is 256. 2 times 256 is 512. So this is 512 over 3. Now let me just point out that the new stuff is to get from this integral and this description of the curve. So given the thing that you want to compute, the new stuff is to go from here to this integral right here. Like the new stuff, the thing that's new about this problem that you haven't seen before is getting to this integral right here. Okay, now after that, this is just doing a calc 1 integral. So use whatever method you want to get from this point to this point. The new thing, again, is to, given a function and a curve and you want to find a line integral, the new thing is to get from this to this. That is the new thing, going from this integral to this integral. That's like the main content of this video. And afterwards, you can just compute this integral any way that you want to, any valid way that you want to.